Hi, Alexis here. I'm the creator and maintainer of Eventuous, a set of .NET libraries that help you building production-grade event source systems. Today I'm going to talk about the difference between dealing with the application state in structure-based system and state derived from events in event source system. I also want to touch on what I often call an unfulfilled promise of event sourcing, where you can literally look at a history and understand what state of your entity or aggregate was at the time that you're interested in. Because I think I have a pretty easy, but at the same time, useful solution for this. So let's start with the first part. Let's have a look at a very simple sample application that I've built to demonstrate some Eventuous features. The application simulates the flow of booking a room in a hotel and paying for it. So it's very simple, it just have a couple of commands. I don't want to go to details, but I will show you exactly what you need to understand during this demonstration. So here are two commands that the application handles. Is the book room command, which has a booking ID, guest ID, room, check-in, check-out day, booking price, prepaid amount, currency, and a booking date. And the second command the application handles the record payment command, which takes the booking ID, so we need to pay for the particular booking, the amount that has been paid, the currency, payment ID, and who paid it. The command service in this application handles these two commands. It essentially creates a bunch of value objects from primitive values that are delivered here inside a command and calls the domain model or the entity method to do what it needs to do. In this particular case, it books the room and records the payment. Since it's event source application, it emits some events. But let's take a step back and try to understand what kind of persistence we would need if we deal with a state-based persistence rather than event sourcing. If we persist the state of this application in the relational database, we would have a table called bookings with all the necessary fields that represent the particular state of the entity. But because we're dealing with event source application, we don't really have a representation of state like this. However, we can retrieve it because we have an object that's called booking state that has exactly the same fields except the booking ID. We don't have the booking ID as a piece of state because it can be derived from the stream name where we persist our events for the particular entity. So if we ignore that part of how the events are being applied to the state, we can easily see how this application works. Now the application has started, I can open this Vague UI and try executing some commands. Now I filled out necessary fields for the command and I can execute it. So let's see what happens. We got a response 200 OK. And Eventuous by default returns a new version of the state and the changes, which is the list of events. Because I'm using EventStoreDB for event persistence, I can look at a stream for that particular entity and find that it has only one event, which contains all the details that we produced in that event. Let's try to execute another command, which is the record payment command. I will fill out the same booking ID as before, and I say that we paid 50 euros. Currency will be the same in euros, and a payment ID would be payment 1. And I will fill out that I paid myself. Now, when I execute this command, it will again return me 200 OK. The new state that says that outstanding amount is now decreased to 50 euros, and it's still not fully paid. The event produced there is the payment recorded event, paid amount 50, outstanding amount 50, currency euro, and stuff like that. So if we look at the entity stream again, we'll find out that it has two events, one room booked as before, and now we have payment recorded. But what happens if, for example, there was a transit failure over the network and the producer of the command decided to execute it again because it looked like it failed? When we execute this command again, we will see that we have now the outstanding amount 0 and it looks like we paid 100 euros. Because we're sending over a command with the same payment ID, it might mean that the command producer hasn't received a success result from the server, so it tries to execute the command again. But our domain model has no protection from this, so ignoring the payment ID, it will assume we paid 50 euros again, and right now the booking is fully paid. If we now look at the entity stream, we will find out that it has two payment recorded events that look completely identical. So it has payment ID, payment 1, 50 euros paid, except for the outstanding amount. And the next event is again 50 euros, same payment ID. By looking at these events, we can understand that if we recorded the payment ID somewhere in the entity state, we would be able to ensure that our command is executed idempotently. So it would ignore the retry of the record payment command if the payment ID is something we know from before. However, our domain model doesn't has this invariant, so we are vulnerable to retries from the command producer. How would we solve this issue if we just persist the state and not events? We will have something like this. We would need to add a new table that's called payments, where the primary key of this table is the payment ID and the foreign key is the booking ID, and the relationship between those two tables will be one-to-many. So one booking has 0 or more payments. By doing so, we can always look up in that additional table to find out if the payment has been registered before. We would be required to change the database schema to create this additional table and create a new foreign primary key relationship between those two. We would also need to execute a migration, rely that some external system contains all the payments that has been registered for each particular booking, so we can retrofit all this information to the new database schema. This sounds like a tedious work, and we might not be able to retrieve this information from elsewhere if we haven't recorded it. So what happens in the event source system is a completely different story. Let me go back to my application and try to solve this issue without changing anything at all. In the booking state object, you can see that there is a handler of the payment recorded event. It's called handle payment. And right now what it does, it just changes the outstanding amounts to the new amount it receives from the domain model. In order to understand if the payment we received has been registered before, we need to store payment IDs. So what we could do is to add a property to the state that would include the list of payments that has been previously registered. Because the state objects in Eventuous are immutable, I also declare this property as an immutable array. So now when we handle the payment recorded event in the state, we can add these payments to the list of previously recorded payments. We have the previously recorded payments array in the property of the state, and we can instantiate a new record to store it. But let's comment this out for the moment and see how our application works before we added this in something that I call unfulfilled promise or event sourcing that has now been implemented. Now the application has started and I can go to Eventuous Time Machine. Since the time machine is hosted in the cloud and it needs to call the application itself through the internal API, we need to expose the application endpoints to the internet. I'm going to use ngrok for this. Now I started ngrok, so my internal endpoint that points to the application API at localhost 5051 is now accessible through the internet through this URL. So I can use this for Eventuous Spyglass. First I need to log in to see this page. Now I can paste the service URL. And because it runs locally in a development environment, I don't need to provide any API secret. You can see that the Spyglass has looked inside the application and found the list of aggregates. Right now we only have one aggregate, which is the booking aggregate that has a state, a type booking state. It has method book room that we have seen previously, and also events being applied to the state room booked, payment recorded, and booking fully paid. When I click browse and type the entity ID, I will be able to see the details about this particular instance, and I will use the same ID that I used before. Now Spyglass has asked the application to load all the events for that particular entity, and we see that it has 4 events: room booked, payment recorded, and booking fully paid. It closely resembles the stream browser in EventStoreDB, so we can see that events are the same. The only difference here is that on the right side we see the state of the entity after event has been applied. Because the booking fully paid event is the last event of this entity, we see the current state of it. And the paid property is true, and we can see that outstanding amount is 0. If we roll back by 1, we see that outstanding amount is still 0, but paid property is set to false, and we can see the event payload. If we roll back 1 more, we will see that the outstanding amount of 50 euros and is still not paid. So everything is correct. Let's go to the IDE again and execute the latest version of our application, which records payment to the list of previously known payments array. I need to restart it. Right now, with the new version of our application, we can go back to Spyglass and see what happens. If I reload the page right now, we'll see that the payment array is populated with 2 payments, and they both have the payment ID. So we can browse back in time and see how the state changes. So after the second payment recorded, we still have 2 payments in the array, but the paid status is false. If we roll back one event, we will see that only 1 payment has been recorded. And if we go to the initial event, there are no payments in the array. So far, so good. So that's what I call unfulfilled promise of event sourcing, that you can go back in time and see how the state changes after the event has been produced and recorded in the entity stream. That gives you a very good understanding how your events affect the entity state, which you use to make decisions. Either you process the command and in what way. But let's finish the exercise and see if we can prevent the second payment with the same ID being processed. Actually, it's pretty easy now. What we need to do is to create a query in a state object that would tell us if the payment has been previously registered. At the end of this object, we will add a new query. Let's call has payment been registered. All we need to do is to ask our collection if the payment is there. In addition to that, in the booking aggregate, we will need to check if the payment has been previously registered. And we need to do it in a method that processes the payment. After being sure that we operate an existing booking, because we cannot record payment for bookings that don't exist, we can simply check if the state dot has payment been registered, payment ID returns true. And if it does, we don't raise an exception, we just return. And we do not raise the payment recorded event again. We assume that the command producer has not received a successful confirmation from the previous command and tries to execute it again. By doing this simple check, we can ensure that our commands are handled idempotency. After the application has started, we can go to Swagger UI and use some other booking ID and execute exactly the same payload, except with the ID, of course. We can look at the Spyglass and see that only 1 event has been produced. Now we can go to Swagger and use the 2, 3, 4 events to record a payment. And we'll use exactly the same ID as before, payment 1. When we execute it and we go here, we see that the payment recorded with payment ID payment 1 was applied to the state and it has been recorded in our payments collection. Let's try executing this command again as we've done before. When we execute it, we'll see that Eventuous has returned us a new piece of state, which is exactly the same as the previous state because there are no events applied and the changes collection is empty. We can confirm in Spyglass that there is no payment being registered because we added this simple check and we changed our representation of state and added new property to it without doing anything else than handling the event differently in the state. We haven't changed any database schema. We didn't need to execute any database migrations, create new tables, or anything like that. Because the state is transient, we can just drop the state representation we have today because it hasn't been recorded anywhere. It hasn't been persisted. We don't need any migrations. Because the state is always rebuilt from events, we give freedom of iterating our domain model and adding new checks and new functionality without thinking about what we had before, as long as we keep our previous events intact and we add the new code to handle these events or apply them to the state, or we add completely new events. I believe this is a pretty powerful feature of event sourcing that you couldn't find anywhere else. But keep in mind, if you decide to store your entity state elsewhere, you actually lock yourself to the state representation, because you won't be able to change it anymore as freely as we have done today. Persisting the entity state somewhere, in addition to storing events in your event store, would mean that every time you change the representation of state, you change the logic of applying event to the state, you would need to execute a migration, as you would have done in the structured-based persistence, not an event source system. Unless you end up in a situation and you really need to read your entities fast, and you cannot tolerate reading hundreds of events in your streams along, you might end up doing something like snapshotting, so you store your state representation now and then. But still you don't store it all the time, because it's still locked to that state representation. You would need to version it, you would need to reapply things if you decide to introduce new mutations of the state based on the previously known events. And you might actually need to drop the full state representation whatsoever and do the full replay. Unless you have this kind of requirement, I don't see a particular reason why you would choose to store the state elsewhere. You would just be able to reproduce the state from events anytime, and you can do any change in the event handling logic and change the state representation as you see fit. Domain model grows, or you find new things and you find new constraints, like we just discovered that certain things must be that important and our domain model wasn't able to handle it before, but now it does, without doing any migration, without deleting or creating any database objects or whatsoever at all, except of changing a couple of lines of code. If you're interested in Eventuous Spyglass, go visit spyglass.eventuous.cloud. The prerequisite that you need to have a publicly accessible endpoint, and you need your application being built with Eventuous, and it needs to have this package Eventuous Spyglass installed from NuGet. That concludes my presentation for today. Thank you very much.